In this video, we're going to look at example 6 in section 5.3 on integration by substitution. All right, so we need to evaluate this integral here. And so in the flavor of this section, we're going to use substitution. So the first step is to always find the u. Find the u in the integral. And this can be often very hard to do. So the more practice you do, the more comfortable you will be with finding the u that will work. Oftentimes we'll choose a u and it's not productive for us. So we have to start over, and that's totally okay. So one thing when we have an issue or a function like this is to try to simplify as much as we can. So we have a radical symbol, the square root. So in order to simplify this down, it would be really nice if like everything under the square root was just one big variable, one big u. So let's try that out first. So let's let u equal 1 plus x squared. So then du with respect to x would be equal to 2x. So now what we can do is see if we can see a du inside our integral. So just to kind of simplify things for notation, we could multiply both sides by dx. So then that just becomes du is equal to 2x dx. So we've taken care of this part of our integral, and we see that we also have an x dx, but we don't have a 2x dx. So what should we maybe do here? Well, I want to substitute in with u's or du's so that I have no x's left. So what we could do is rather than substituting a du for 2x dx, I can divide both sides of du by 2. So now that 2 cancels, and I see that I have a x dx, an x dx here, so I can just substitute du over 2 for x dx. Okay, and I'll use a little color coding so we can really see this. So here's going to be my u. Here's going to be my du over 2. So that's what we're going to substitute in for x dx. And we'll substitute u for 1 plus x squared. So let's just try this out. Let's see what happens to this integral when we make this substitution. So this integral will then be equal to the square root of u times du over 2. Now that du over 2, that's equivalent to just multiplying the entire integral by 1/2. We're just multiplying here. Du divided by 2 is the same thing as du times 1/2 is the same thing as multiplying this integrand by 1/2. So that's equal to 1/2 the integral of u du. So have we simplified our integral? Yes, we have. Now we just have an integral of u to the 1/2 or square root of u. So we can compute that antiderivative. So let's recall we just use that kind of reverse power rule. So that would be u to the 3 over 2 divided by 3 over 2 plus c. So we can simplify that a little bit. We still have the 1/2 hanging out. U to the 3 over 2. Oops, and I'm going to give myself more room. So feel free to give yourself more room too. So it's equal to 1/2, 2 times 3. Recall dividing by a fraction is equivalent to multiplying by its reciprocal, times u to the 3 over 2 plus c. So now we get some cancellation, which is nice here. The 2's cancel. So we're just left with u cubed square root, if we go back to using radicals instead of fractional exponents, over 3 plus c. Not too bad. We were able to compute that antiderivative. Okay, I shouldn't box this though, because we're not done yet. What is our final step? Now we have to substitute back in for what we used for u. So we saw that u we used as 1 plus x squared. So we need to substitute that back in. So we need the square root of 1 plus x squared, all of that cubed, because we're cubing u. So we need to cube 1 plus x squared. Write that a little nicer here. Square root over 3 plus c. So our final integral becomes square root of 1 plus x squared cubed over 3 plus c.